Okay, good. Quick note before I begin. David and I conceptualized this conference a long time ago, but it was entirely David who realized it. So I would like to thank you, David, for your unlimited energy and unfailing optimism. I will speak about what I call the problem of the spatio-temporal explanatory gap. We'll give a very high-level characterization of this problem, then move to an example, and then discuss the problem with respect to this example. So I will begin with you might call it manifest time, the manifest image of time, a pre-theoretical functionalist characterization of a system of time. Here are some aspects. So I'm thinking of system of time very broadly, very intuitive, as a system that organizes a domain of things in a manner. And that includes succession, or temporal order, duration, which is a magnitude, persistence of things, motion of things, and more generally change. Okay, and now I want to say that such a system of time is realized in conscious human experience. So these aspects, they're not exhaustive, of course, there are more, but these aspects are experientially realized. And these aspects are also realized in contemporary physics, which is short for, they're realized in standard relativistic space-time systems. So we have such a system in conscious human experience, and we have such a system of time in contemporary physics. The same can be done for a system of space, but I don't have much time, so I'll just do it for time. Now, these two realizations, they're massively different. Very broadly put, in human experience, time organizes things in a manner that is non-space-like, which I will also abbreviate as dynamic. And in contemporary physics, time organizes things in a manner that is space-like or static, right? So here's the problem. The problem is to connect these two systems of time, one in human experience and one in contemporary physics. And this challenge of connection has two parts. A, how does experiential time differ from physical time? And the second part, why does experiential time differ from physical time? Okay, I find this problem very important and very difficult. I will just look at A, how does experiential time differ from physical time? And I will look at only at one aspect, namely number 4, motion. So this talk will be about motion. And now I'm going to give you an example. So here's an example of a visual experience that I hope you're having in a second as of an episode of motion. Here we go. Okay, so that is my example of an episode of motion. You're having a temporal experience of that entire episode. Now I'm going to give you roughly a physical representation of that episode which you visually experienced. It's this one. Now let's look at them side by side. So on the left we have a space-time representation of the entire episode, and on the right we have, this is like a comic strip, a representation of the way we visually, you and I hopefully, visually experience that episode. Now of course I just gave you the example where the dot goes around twice. You go around a few more times to get the helix. So let's compare them. In physical time or physical space-time, our object moves. Sure, as in some sense has different locations, different times, but what we can say, what we should say most perspicuously here is that the object has the shape of a line, and that line or line segment, and that line segment has a three-dimensional shape of a helix. But in our visual experience as of the episode of motion, our object appears very differently. Here the object always is point-shaped, which I'm going to treat as approximately zero-dimensional. And that point goes around in a circle. But importantly, in your visual experience, just focus on what is phenomenally given to you. There is no helix. Right? So that shape just isn't there. Now the problem of the spatio-temporal gap is to explain how these two representations are connected. So what sort of problem is that, and how deep is that problem? So it depends on the framing. So if you're a naive realist, you might say that, well, there seems to be a dot going around in a circle. This is how the episode is given to us in human experience, and that's because reality is just like that. So human experience is a reliable and perspicuous window onto reality. And the physical helix representation, well, that doesn't go very deep. It's just a good tool to make predictions, right? Some sort of instrumentalism you might have in the background. But it isn't a perspicuous representation of reality. So human experience is a much better window on how things really are than contemporary physics. So that is not at all the framing that I prefer, and I won't talk about that much more. Here's what I'm just going to call naturalist, realist way of framing this. So reality is, well, maybe not fundamentally, but more or less the way contemporary space-time theories see it. So the episode of motion really involves an object that is line-shaped and has the shape of a helix, but we don't experience that episode in this way. We experience it in a very different way. So this entire sequence of locational states of an object is very different because it doesn't give you a phenomenal character of a helix. So if the problem is framed in this way, it becomes to my mind, urgent problem of explaining how human experience, in this case, visual experience as of motion, fits into reality. Okay, so now I'm going to say something about what the difference is on the left and on the right. We understand the helix fairly well, so I'm going to start with that, and I will give an account in more or less familiar terms, but I will introduce some new concepts here. And then I will go to the account of motion as given in human experience on the right. Okay, so we will begin with space. Familiar space is a system of location. So we just begin, I'm trying to keep things very simple. So begin with Euclidean space, like a plenum of a manifold of points, and they like P1, P2, and they stand in certain relations, and the pink relation is the distance relation between P1 and P2. Distance isn't primitive for me, right? It is a measure of the path between P1 and P2. So there's lots of geometrical structure in that manifold, and it gives the intrinsic geometrical structure of the space. Now the question is, so how does that system organize material things? Right, so how does it organize things so that they are apart in certain ways? Because this is just about the geometrical objects, these points and regions, right? So the standard view is that this intrinsic geometrical system performs its function of organizing material things in such a way that things inherit. There's an inheritance again. We had that yesterday, the Oris talk. So they inherit their spatial relations from the intrinsic structure of the space by being exactly located in the space. So if X is exactly located at P1 and Y exactly located at P2, and P1 and P2 have this pink distance, then X and Y have this distance. So this is what I'm going to call a functional geometrical account of familiar space as a system with an intrinsic geometrical structure that is conferred on the domain of material things by location. So the standard view in contemporary physics, as I understand it, is that space-time is a static system of location. So on the whole, it is space-like, pretty much following the model I just gave. So if you look at time now individually for a moment, so understand time as a one-dimensional manifold of points with certain geometrical structure, right? Think of it as the structure of the real line. And or a discrete structure. It doesn't matter, but these points, these moments are literally geometrical points that stand in distance, geometrical distance relations to each other. So all of that is analogous to what I just said about space, just one-dimensional, but the rest is analogous. So how does this system perform organizational functions? Why is that a system of time? Well, it's analogous to the spatial case. An object or a thing or a state, doesn't matter, that is exactly located to T1, and an object or a thing Y that is exactly located to 2, and they're only exactly located at these points, inherit their geometrical temporal relations from the system by way of exact location. Okay, so time is understood as a geometrical system that transfers its intrinsic geometrical temporal relations onto its domain by location. So putting this account of time together with the account of space gives us the standard picture of space-time as a unified, static or space-like four-dimensional system of locations. So the pink cubes, that's just the three-dimensional space. We just understood it. Different ones. Now the different points in these three-dimensional spaces are geometrically related along a further dimension, temporal dimension. These are the bright pink lines. And if we put it all together, we get this four-dimensional space-time, so a four-dimensional manifold. We're going to leave out relativity. So important thing for me is this is a geometrically four-dimensional manifold, so they're all related geometrically along four dimensions. And it's very easy to understand how our object changes in such a way that it receives this helical shape. The helix is a region in four-dimensional space-time. Our object, the object that we visually experience, is in reality exactly located at that helical region, and that helical region transfers its four-dimensional shape to the object. So that's the picture of space-time as a static 4D system of location. But we already saw that this is not how we experience motion. So we need a different account of time. We need an account of experience time as a non-space-like or dynamic system. And I will now introduce you briefly to what I call a system of relativization. I have different levels of resolution concerning the way I introduce it, so I'm going to introduce it in the most intuitive way I can by going away from motion for a second. So suppose I do this, I clap my hands like this. So you got two claps, and they're temporally separated. So here's the static picture again. So time, this is now part of space-time, is a system of location. So the first clap and the second clap, they have absolute existence. And they are exactly located at different moments of time. And since they have absolute existence, they have trans-temporal coexistence. And their temporal order in this static system is a geometrical temporal distance relation. Sorry, not a distance relation, ordering relation, which has a certain length. That's why we also have a certain duration between these two claps. And these relations, so all the stuff that I'm putting into the pink line here is inherited from the system of time. So it's all purely geometrical. This is trans-temporal existence and cross-temporal geometry. So in order to understand how, and this is my aim, right? I want to explain the way we see motion phenomenally but I want to not just describe phenomenology, but I want to explain the structure that gives rise to that appearance. And I claim that we have to reconceptualize the picture on the left, where the clapping is a static process. We have to reconceptualize it from the ground up. And intuitively, the first step we need to do is we need to give these claps each an irreducibly temporal existence. So there is no absolute existence. They don't just have being anymore, they have irreducibly temporal being. Now, in metaphysics of time, generally in the philosophy of time, almost everyone, when they hear that, immediately think of tensed, primitively tensed existence. But this is not at all how I think about this. So everything that follows now has nothing to do with tense or with any concept or property of past, present, and future. I have a lot to say about this, but I won't use my time to criticize. I'll use my time to propose something. So the temporal existence is not tense. The temporal existence is tenseless. Think of it as the clap existing, the first clap existing before the second clap, and the first clap going out of existence before the second clap comes into existence. So these notions of existing before, coming into existence, going out of existence, and if we're talking about persistence, which we're not, staying in existence, these are irreducibly temporal forms of existence. So the way the first clap and the second claps are linked is not a relation at all, because relations, temporal relations, require the coexistence of the relata. So there is no trans-temporal coexistence. There's what I call a chain of existential transitions. That is an important concept which I'm not going to unpack carefully, but the idea is that one state comes into existence, goes out of existence as the next state comes into existence. That goes out of existence as the next state comes into existence. So each one state going out of existence, the next state comes into existence is an existential transition, and a chain of such transitions will be a dynamic process under some further constraints. So that's the intuitive picture, but I'm not yet happy with just talking about coming into and going out of existence. Just take that as a primitive. So the next step is to geometrize that, but in a different way than the standard view. So it's very important to me that the way I want to understand time as a dynamic system with dynamic processes is such that all of these aspects I mentioned at the beginning and more can be explained systematically. So it's not good enough to have one example and then describe that, slap a label on that. So I want to give a systematic explanation, and my hypothesis is that the best way to do this if there in the background there's a time with moments. These moments are points on a line, so it's the same intrinsic geometrical structure, and they all have absolute existence. Okay, so the moments have absolute existence and they have trans-temporal coexistence. But here comes the main difference. Think of time as a geometrical system, or a system with an intrinsic geometrical structure, as performing its organizational functions in a fundamentally different way than a system of location. Think of time as having this intrinsic geometrical structure, but it performs its function of organizing a domain of material things in such a way that it never transfers its temporal structure, its temporal relations onto this domain. It never does that. It's rather that this temporal structure plays the role of what I intuitively call an envelope of attribution of non-temporal properties. So all of that structure appears in the domain of material things as temporal ways of being for that. And the only new primitive I need to do that is relativization. So the first clap exists relative to T1 and only relative to T2. It has no absolute existence. It does not exist relative to T2. It So that's what it means that it goes out of existence. And analogously for the second clap, it only exists relative to T2, it does not exist relative to T1, it has no absolute existence, so it comes into existence at T2. And together they form what might be called a dynamic process. So I'm going very fast, I know, but I can give a systematic account of these intuitions about going out of existence, coming into existence of material things in terms of an absolute system of time with a geometrical structure and a relativization. Okay, so I moved to the clap example to get away from space for a moment, but it's now time to bring space back in. Can someone tell me how much time I have left, because I can't see my...
You have like 9 minutes left, but you know, if you go a few minutes over,
David,
at the expense of the Q&A, that's also. Oh, I'm sorry. So you have like technically you have like 8 minutes left, but if you go over,
it's fine.
If you go over a bit, that's also fine. Yeah.
Okay, great. So here we are, right? Now we want to bring space back in. So we're going to do what is completely standard. We'll think of space, familiar space, as a three-dimensional system of location. These are we have the space-time on the left. Now we want to understand why the object does not appear helical to us, right? So, but right now we're not even talking about appearance yet. We're just characterizing a conception of space and time. So space is a three-dimensional system of location, and time is a one-dimensional system of relativization. So let's bring them together. Each point and region in 3D space exists relative to all moments of time. So none of these spatial points have an absolute existence. They are all temporally relativized in their existence, and all their relations are temporally relativized. So what we have here on the lower and the upper part of the figure on the right is the numerically identical three-dimensional space existing relative to different moments. Okay, so this gives us what I call a hybrid space-time, a temporally relativized space, which I abbreviate as R3D versus 4D, the 4D system on the left. Now let's place our object in there. We view the object as approximately spatially zero-dimensional. Relative to T1, our object is in one, so is exactly located in one spatial point. And the same object, this object relative to T2, is exactly located in a different spatial point, or at a different spatial point. So taking these two locational states together, we have one object exactly occupying different points in space relative to different moments. So that gives us change. If the points in space through which the object moves, in the sense that the object is in different parts of that region relative to different moments, and the region that is the whole of these points, if that is circular, we have circular motion. Now here's the key thing. Since it's a system of relativization, no locational state has absolute existence. Nothing in space relative to different moments is cross-temporally related, strictly speaking, and specifically is cross-temporally geometrically related. There are no cross-temporal relations of distance or anything else. These are all spatial relations relative to moments. These geometric relations are not relations across time. This means that the dots, momentary states, do not add up to a cross-temporal helix, which they do in a four-dimensional system of location. So that explains, on the right conception, why this object moves but is always point-shaped. It undergoes circular motion because the spatial region through which it moves is circular. And since it's a system of relativization without any cross-temporal geometry, there is no helix. So it explains the absence of the helix. Now, final slide. We now want to go back to reality versus human experience. So I'm a representationalist, and I think of a human temporal experience as having a representational content that represents space and time as having a certain structure. And my hypothesis, which I put to you, is that this structure of space-time, as represented in all of human experiential content, is R3D. This is a relativized three-dimensional space. Now, I haven't said much about the spatial geometry because it is not Euclidean. My focus has been on time understood as a system of relativization. So if we understand space and time as represented in human experience as of extended episodes, then this account of the structure explains why we do not have phenomenal visual experiences as of a helix. So that is the answer to the how question. How do they differ? Next up would be the why question. So why did the human mind evolve in such a way that space and time have a structure in human experience that is so massively different from how space and time really are? So I'm on this question, but fortunately I'm out of time to go into it. So I'll stop here and thank you.